All right, we're back. We are on page 15 of note 17 of Calc C, and what we're going to be doing is finding polar areas, which we've been doing for decades, it feels like. All right, so let's see. Find the area of the small region shown in the figure to the right. So this is the figure to the right, the area of the small region. Ooh, what's the small region? Well, there's only one region that I think is like the smallest, so I'm going to go with that. I think it's this one. So we're going to need an intersection point that we, as humans, can't really find. Because, well, or could we approximate cosine with its Taylor series and try to solve it? Even then, I don't think humans would really do a good job of solving that. But we need to figure out the collision point because we're going to do basically, this is like our old standby thing. We're going to find this angle, that'll be our collision point. Until we get to that angle, we're shooting out lasers and we're hitting this thing, which is theta over 2. When we get to that angle, we'll switch over to cosine and do that until pi over 2. So once you got all the strategies down, you kind of know what you're doing. This is, by the way, the like zoomed out version of this picture. That is a little region. It's like right in there. So let's see, we first need to find the intersection. So I'm gonna like set this up. I need to use a calculator to do all of it. So I want to know when cosine of theta equals theta over 2. Theta is approximately whatever. It's gonna be a number, an irrational number. There's no like simple intersection point. And then what I'm gonna do, so I'm gonna say equals k. And then I'm gonna do 1/2 the integral from 0 to k. So remember, when we're going between 0 and k is the intersection point. It's the theta over 2 thing. So it's going to be theta over 2 squared d theta, and then plus 1/2 the integral from k to pi over 2. If you know how polar curves work, it pays off like forever. If you're confused about it, you got to really go back and watch the videos about graphing things in polar and also polar equations of circles. Circles are me. I don't know if they're the trickiest. Limacons, they all have their own little things. So we got to know all of them. So because this goes 0 to pi over 2, pi over 2 to pi, I only need to go from the intersection to pi over 2 of the cosine graph to get the area that I'm looking for. So then that'll be cosine squared of theta d theta. A lot of calculator work here. So let's switch over to calculator and see if we can do it. Here we go. All right. So first I need the intersection. I'm just going to use solve. You could also graph them in rectangular and find the intersection. Like that would totally work. Intersections in polar, you can't find them on the calculator because they're complicated. There's like a lot going on. Like I feel like they could make the calculator so that you could find the XY intersection potentially, but like I don't blame them for not doing that. But you can't find like collision points. So we have to solve this either using the rectangular graphs or just using solve, which is what I'm going to choose. So we get this. So I'm going to store that as T1. Well, I said I would store it as K. So K, I'm going to say it's the right side of the answer. It's a weird way of doing that. And I wouldn't do that on the handheld probably. What I would do on the handheld is I would just do that and then go over here and delete this and replace it with K colon equals. And then it stores it. Right literally just returns the right-hand side of something, like 3 equals T. The right-hand side is T. It returns T. Left, 3 equals T. The left-hand side is 3, so it returns 3. So that's what I did the first time. And I shouldn't have bothered because then I had to explain all that. All right, 1/2 integral. Can't forget the 1/2. That's like that's the killer. T over 2. Yeah. Then we're squaring it. dt plus 1/2 k to pi over 2 cosine of t squared dt. All right. So this I think is going to be the area. I have no sense whatsoever if this is accurate. I mean, I'm confident that we set up something that works. Rounding k is annoying. So I think it's 1.030. And then my approximation, it's like really tiny, 0.070. Let's like go back and look and see if there's like any, I don't think looking at it like without getting back to the notes yet, I don't think there's any way that I could like estimate this accurately at least. I mean, I can tell you it's smaller than something, and that's often useful. I mean, it's definitely smaller than like 0.5 times 0.25, so 1/2 times 1/4, 1/8. Smaller than 1/8, which is 0.125. This is like half of 0.125. So like, I mean, that wasn't not useful, I think, to work through. All right, so that's that. Let's do this one. I will say at the end of this video, there's another page that's just old AP questions. I'm not going to record those yet because I think their solutions are readily available. And when I get done recording all of the rest of my notes, which contains the second half of my Calc CD class, which is multivariable calculus, which is that going to take me 50 hours? I don't know. I'll come back and I'll do them eventually. There's a couple things on the back burner for that, but let's see if we can do this. Consider the curves. 1 minus 2 cosine theta and r equals 1. All right, so what does 1 minus 2 cosine theta look like? Nice of me to not leave a graph here. So what does a rectangular look like? Because that's the key. 1, 3, -1. So it's a negative cosine. So here, 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 here. So we do inner loop. So we need to go here. That's going to be -1 on the x-axis, 3 on the x-axis, and then at pi over 2, we're here, 3 pi over 2 will be here. All right, here we go. Boom. Then we're going to go like this, like this. Doing this all wrong. Oh, you know what I'm doing all wrong? I am doing it all wrong. I'm like off my, when you get to pi, you're at 3. That's my problem. So this, here we go. -3 on the x-axis, -1, 1, -1. All right, inner loop, here to here to here, okay, to here. A good graph, which I'm not really creating, a good graph will help you solve this problem. Then r equals 1 is just a circle with a radius of 1. Just kind of like that. Things got better on the right-hand side. All right, the area between the loops of the limacon, I need to know these. I need to know this value so that I can like work out what's happening. So I'm going to do the full limacon minus the inner loop. That's the area between. So full limacon minus the inner loop. So I need to know when cosine of theta equals subtract 1 divided by -2, so 1/2. So that happens at theta equals pi over 3. Okay, so you exit the inner loop for the first time at theta equals pi over 3. So here, this is all inner loop. It's all inner loop. You're going to exit the inner loop at pi over 3. Then you're going to keep going around. So this is pi over 3 when you hit here for the first time. Keep going around. This is at pi. So if I do pi over 3 to pi and double it, so here we go. We're going to do 2 times 1/2 the integral from pi over 3 to pi of 1 minus 2 cosine of theta squared d theta. Okay, so that's the full limacon. Now I need to subtract off the inner loop. So what I'm gonna do for the inner loop is I'm gonna go from 0 to pi over 3 and double it. Right, 0 to pi over 3 is half of the inner loop, so I'll just double that. So minus 2 1/2 0 to pi over 3 of the limacon again. Definitely storing this on the calculator. Okay, that's going to give us the whole area of the limacon. Parentheses. And I think I'm going to get a decimal. Inside the, should I just get that answer? Inside the limacon, not inside the circle. So I think inside the limacon, but not inside the circle. Is there like a fast way to do that? So like, what do I want? Inside the limacon, but not inside the circle. I think what I'm going to do, so inside the limacon, not inside the circle. I'm looking at this, right? So this, if I integrate the limacon from pi over 2 to pi, it gives me all of this. So pi over 2 to pi gives me all of this. Then I'll subtract off this quarter circle, just maybe using geometry, and then I'll double it, and that'll give me the area inside the limacon that is not inside the circle. That's my plan. So I'm going to do pi over 2 to pi gives me this. Double it gives me the full thing. Subtract off a quarter, well, subtract off half the circle. So let's try that. So inside the limacon, not so it's going to be 2 because I'm doubling it. 1/2 pi over 2 to pi of the limacon. It's like the actual answer becomes sort of immaterial. It's the process that matters the most. So that's the full, it's not the full limacon, that's the full limacon to the left of the y-axis. So we're kind of missing these little guys. They're just not there. We just never found them. And now we're going to subtract half of the circle. So it's a circle that has a radius of 1. So an area of pi. So let's just subtract pi over 2. Okay, there we go. Now, find the area inside the circle, but not inside the limacon. This is like the opposite question. Inside the circle, not inside the limacon is kind of like this symbol. It looks like a symbol to me. So what are we going to do? I think we can do the quarter circle, right? Just take a quarter of the circle and subtract off the limacon from here to here. But we know what that is. That's going to be from pi over 3 where you end the inner loop the first time. It's the first time you exit the inner loop to pi over 2. So I'm going to do 2 times a quarter of the circle, so basically half the circle. And then, oh, did I forget that last time? No, I did not. Okay, 2 times a quarter of the circle, so half the circle, minus the limacon from pi over 3 to pi over 2, times 2. That's my plan. So half the circle minus, what did I say? The limacon, so 2 times 1/2 from pi over 3 to pi over 2, 1 minus 2 cosine of theta squared d theta. There we go, I think. Okay, and again, we're gonna use a calculator, but I don't think the calculator is gonna give me any like great clarity here. Area bounded by both the outer and inner loops of the limacon and by the circle. What? Outer and inner loops of the limacon and the circle. Outer, okay, I'm gonna shade this in because I think I know what it is. I think that it's this. Because like any other region is only bounded by 2 of them, like the outer loop and the circle or the inner loop and the circle. I think this is the region that I want. So what do I want to do there? I need to do, oh, okay, maybe. I don't really know. So this I can just add up, right? That's pi over 3 to pi over 2 of the limacon. That'll be good, get that. Then I think what I want to do is the quarter circle here, quarter circle minus half the inner loop. And then you just double everything, right? Because you need to do that. So that's my game plan. So first we're doing, I'll like write it over here and then move it. First we're doing the limacon from pi over 3 to pi over 2. Pi over 3 to pi over 2 of the limacon. 1 minus 2 cosine of theta squared. I might not even get these values on the calculator. Like, what's the difference, right? You've seen me do that a million times. Okay, so that's this this part here. Now I want to do quarter circle. So quarter of the circle is pi over 4. And I want to subtract off. So I want to subtract off half the inner loop. I'm going to subtract off not the half of the inner loop that I'm looking at. I'm going to go from 0 to pi over 3 and get this. So 0 to pi over 3 will give me this. I'm going to do this quarter, in my mind I'm doing this quarter circle minus this half. But like it's fine, same difference, right? So minus 1/2 the integral from 0 to pi over 3 of 1 minus 2 cosine of theta squared d theta. Okay, so I want to like add these together. So I'm going to move things around. I want to add these two together and then double it. So then 2 of everything. This I think will work. I mean, I could like go through and annotate what I did, but I think that this video is probably 1,000 years long. So I don't want to do that. If you want to see where these things came from, just rewind and watch me describe them again. I think this works. Should I punch them in? I don't think it'll be the end of the world to punch all this in, so I'm going to do it. But I mean, if you're done with the video, like, get out of here. And I will see you in some other video, I'm sure, but it won't be the video for the next page of these notes. So I'm going to store r of t as 1 minus 2 cosine of t. All right, so I want to do integral r of t squared. So I'm doing a, comma t, comma pi over 3 to pi minus integral of r of t squared. I should just square r of t and store that as a different function, but whatever. 0 to pi over 3. So I think that's right. Okay, so I'm gonna go with the decimal. 8.338. 8.338. Filling these in on paper just so I have it, I guess. Part B, it's let's borrow something here. It's the integral from pi over 2 to pi. Pi over 2 to pi. And then we want to subtract off half of a unit circle. So that's pi over 2. 7.15, nope, 7.142. 7.142. Next one we want to do almost the reverse. Almost. Pi over 2 minus pi over 3 to pi over 2. 1.402. And then finally this guy. All right, so let's see. We want to do 2 times 1/2. Let me just borrow somewhere. U. Okay, so pi over 3 to pi over 2. I probably could have found a pi over 3 to pi over 2 in there. Okay, that plus pi over 4 minus, let's paste down the integral again, 0 to pi over 3. This, like, in my mind, this makes a lot of sense. I think that this one is almost certainly right-ish. 0.65. Did I forget a 1/2 on there? I did. Seems suspiciously small. Did it? I don't know. 1.196. Approximately 1.196. All right, I'm gonna go back to the video, to the notes, I guess. You can take a look at this, and then someday when when they just invent more time, I'm gonna go back and do these AP questions. Till then, you can like look them up. They're all freely available, I'm sure, somewhere on the internet. Anyway, that is page, what is this? Page 15 of note 17 of Calc C. Technically, you're done with Calc C. Calc BC, if you've watched from the first video of AB to the last video here, you've done all of Calc BC. And if you're about to take the AP exam or whatever, good luck. If you're about to study multivariable with me, keep on going. So I will see you in the next video, I'm sure. So see you there.